On to the next part of this chapter, which is the discriminant. Now here's the quadratic formula. It is this part, the bit under the square root, which is the discriminant. Now that can tell us a lot of things about the graph and about the function. So we've got three possibilities. B squared minus 4ac can be bigger than 0. B squared minus 4ac discriminant can be equal to 0. B squared minus 4ac can be less than 0. If it's bigger than 0, then the graph will look like either one of these two things. Or it will cross twice. You'll have two solutions, two roots, where it crosses the x-axis. This is obviously where I would be bigger than 1, bigger than 0 rather. This will be where I is negative, happy, sad. What about if it's equal to 0? If it's equal to 0, then the graph will look something like this. Or so if it's equal to 0, it's where the graph just touches the x-axis, it just brushes the x-axis and then goes back the other way. In which case it's got one solution, one root. It's called a repeated root, or it might be called equal roots, because the two solutions you normally get are obviously equal. If it's less than 0, then this part is negative, is where you're not going to have any solutions, because I said you can't square root a negative and get a real solution. So it might look like that, or it might look like that, but that's the x-axis. So it won't cross, it won't touch the x-axis. So no solutions, no roots. Now you're sometimes asked to prove that a quadratic equation has two solutions. If it asks you for that, you're trying to prove the discriminant is bigger than 0. Prove there are no solutions, you'll prove that the discriminant is less than 0. So if this talks about solutions, numbers of solutions, it's talking about the discriminant. Remember that. So on to example 13. We have the function of x is equal to x squared plus kx plus 9, and we're told it has equal roots. Now you need to remember straight away, equal roots means the discriminant is equal to 0. And that would normally be 1 mark in the exam. So in this case, a is 1. Remember, when there's nothing in front of the quadratic, it's coefficient of 1. B is k, c is 9. So let's slam those into this. So k squared minus 4 times 1 times 9 equals 0. K squared minus 36 equals 0. K squared equals 36, therefore k is plus or minus 6. So two possible values for k. Example 14. This time we've got x squared plus 4x plus k equals 0. And we're told it has two distinct solutions. When it says distinct solution, it means separate solutions, it's not a repeated root. Now two solutions means b squared minus 4ac is bigger than 0. So a is 1, b is 4, c is k. So we have 16, 4 squared is 16, minus 4 times 1 times k is bigger than 0. 16 minus 4k is bigger than 0. All of that to the other side. 16 is bigger than 4k. Divide by 4. 4 is bigger than k. Write k first. Pointing towards the k. K is less than 4. So the possible values of k is less than 4. So whenever k is less than 4, you are going to get two solutions. Now, this question is sometimes written as, it causes problems, x squared plus 4x plus k equals 6. You've got to remember, before the discriminant, you must make it equal to 0. So in this case, x squared plus 4x plus k minus 6 equals 0. That would be C, k minus 6. Okay, that's everything for exercise 2G.